Okay, this video is about linear and angular speed or velocity. Linear and angular velocity is usually the word that's used, but I wanted you to know that that's same thing as speed. So two types here, and I'm going to kind of give a little analogy of each of these. The main thing I think of is with a wheel, like a little bicycle wheel or something, or let's just do an old-fashioned wheel or whatever. So two types of speeds here. One of them is if you were to, let's actually say it's a bicycle. It makes more sense if it's a bicycle. There's our seat, right? Bar, handlebars, comes down. Man, that's good drawing. Whoa, those handlebars are way out there. Gotta lean way forward to reach those. You know, the old little girl bikes with the little tassels coming off of them. Anybody have those when they were growing up? I loved it. And then there's pedals down here somewhere, but I can never draw those in correctly. Okay, so either way, when you talk about angular speed and you're looking at a wheel, angular speed is the rate that this tire is turning, basically, right? So if we picked a point on the tire and it starts spinning, going around and around, angular is how fast that angle is changing, right? So it's rotating around and around, doing all these revolutions. Angular speed is measuring how fast it's making those revolutions, basically. Linear speed is a measurement of speed in a line. So that's kind of like measuring this outside of the circle. Basically, as you're riding this bike, if you pick a point on the tire, as it starts rotating, it kind of paints out this path, right? The tire goes around and it leaves behind this little string, goes around and it moves down the road like this. The speed that you're going down that road from this point, tire makes it circles, tire makes it circles, and lands to there is what your actual linear speed is, just like you would know a regular one. It's just going to be based off of angles and circles. Okay, so some formulas here. Angular speed is described in this weird, it's another Greek letter, but I'm just going to call it the fancy W for you. And that's found by taking the angle, the theta, and that's how many revolutions, or sorry, the number of degrees that it's traveled in a certain amount of time, and you divide it by that time. So this is your angle, obviously, and this is going to be the time that it took you there. And it's a regular old speed, distance divided by time. D equals RT, but R rate is distance divided by that. Linear speed is this fancy W. Sorry, fancy V. And then it's got S over time. And hopefully you didn't forget what S is already. This is arc length, which has a formula of R theta. So linear speed can also be looked at as R times theta over T. And again, I mean, that's basically the arc length would be of the whole circle. We just want to know basically how many times did that circle turn to be able to tell you how many loops it made around that 360 degrees. S is arc length. Don't forget that theta has to be in radians. It's like percents. You can't really do calculations with percents. You have to change it to a decimal first. Same thing with degrees and radians. Okay, first problem here says, a boy rotates a stone in a 3-foot long sling. That's a measurement, so it must be important. At the rate 15 revolutions every 10 seconds. Find the angular and linear velocities of the stone. Okay, so this word right here is key. A revolution is one turnaround. So when a wheel goes a full turnaround, that's a revolution, or a sling, or whatever it is. When you make a full circle, you've made a revolution, which means you've gone 360 degrees or 2 pi radians. 1 revolution is equal to 360 degrees, or 2 pi. So 1 revolution. That one is too far away from that word. I get so picky, that's what takes these videos so long. So 1 revolution is 360 or 2 pi degrees. Now, if this kid makes 15 revolutions, then your angle theta is 15 times 1 revolution. Now notice I'm taking 2 pi because our theta has to be in radians, so why not just go right to radians? Okay, there's our theta. Now we also need time and a radius. So it says right here that it's a 3-foot long sling. So if you picture this kid, dumb kid, with a sling and he's spinning it around in circles above his head, right? That's a circle. The sling, the length of it is that 3 feet, which means that's the radius. So our radius equals 3. And then the time, it says it does 15 revolutions every 10 seconds. So our t is going to be 10 seconds. All right, let's find them. Our angular speed, fancy W, is going to be our angle 30 pi divided by 10 seconds. It's going to be 3 pi feet per second. Doesn't really make a lot of sense, so that one we would probably want a decimal approximation. So 3 times pi is 9.42. So it's about 9.4 feet per second. Oh, I'm sorry. Angular speed is talking about the angle. So it would be 3 pi radians per second, not feet per second. So 3 pi radians per second. There's no radius involved in this. I got myself confused because the radius is 3, but this also reduced down to that. 3 pi radians per second. And again, angular velocity, your answer has to do with angles. So it wouldn't have had a feet in there because you don't measure angles in feet. You measure them in degrees or radians. Anyways, okay. Next part says to find the linear speed. So my fancy V here, it looks more like a square root. Get rid of that little guy. V is S, or R theta, over the time. R this time is being used. Theta is 30 pi over 10 seconds, which is 9 pi. That one's going to be feet. Actually, it's called foot radians, but we're just going to call it feet per second. And that again is approximately 28.3 feet per second. Okay, linear and angular speed. If you notice, this V right here is actually the same thing as R times your fancy W, your angular speed. So I could have taken just 3 times 3 pi if I wanted to and saved myself a step. Okay, a woman is riding a bicycle whose wheels are 30 inches in diameter. 30 inches is a number. The word diameter sticks out to me, so I'm going to circle those. If the wheels rotate at 150 revolutions per minute, find the speed at which she is traveling in miles per hour. So we are doing miles per hour. What is that going to be? Linear or angular? Talking about miles per hour. Remember, angular, we're measuring in angles. which would be either degrees or radians. Miles per hour means we've got to do linear speed. Okay, 30 inches in diameter, that's D equals 30, but we don't want D, we want R, which is half the diameter. Okay, next component is to find your angle. So theta, 150 revolutions. So 150 times going around the circle. Every trip around the circle is 2 pi radians. So our theta is 300 pi. Now to find linear velocity, we need r, got it, theta, got it, and then we've also got to have t, which is time. Now it tells us that it does 15 revolutions per minute. So our time is going to be in minutes. But since it doesn't say, like the last one said, per 10 seconds, this one just says per minute, then its time is 1 minute. All right, so linear speed, V, is R, 15, times theta, 300 pi, over 1 minute. Okay, it was 15 inches. So that becomes 4,500 pi. Okay, multiply, all right. 45, 2 zeros, 4,500 pi, which is about, hit the wrong key. I swear this calculator hates me. Everybody hates me. That's 14,137.2. Now that seems like a whole lot of inches per minute. Inches and minutes are kind of weird to visualize, but if you'll notice, the problem actually asked for miles per hour. So you need to take your 14,137, I'm going to leave the 0.2 off. That's inches per minute. And you've got to do conversions. Hope you guys remember conversions. To get rid of this inches in the top, you're going to multiply by 12 inches per foot. That'll cancel those inches. Then you got to multiply by 5,280 feet in 1 mile. Feet cancel each other. So at this point, we would have 14137 times 1 over 12 times 5,280, and that is miles per minute. We want miles per hour, so one more conversion to do. We've got to multiply by 60 minutes over 1 hour, and you get rid of those minutes canceling. So I need 14,137 times 60 over 12 times 5,280, which is about, that is about 13.4 miles per hour. Now, that sounds more familiar. The lady's riding her bike, 30-inch diameter, 150 revolutions per minute. She's moving 13.4 miles an hour, which still seems fast, but 150 revolutions per minute, I guess that's fast. I don't like bikes. I don't ride them very much. They hurt my bottom. Okay, linear and angular velocity depends on what you're given. You've got formulas for it. Plug it in, see what you get.